Introduction to Mathematical Sets. Hello everyone, welcome to our lecture on Introduction to Mathematical Sets. We are going to look at the fundamental concepts of sets in mathematics, which are essential for understanding various topics in higher mathematics. Objectives. By the end of this lecture, you should be able to understand what a set is and identify different types of sets, and you will learn how to use set notation and representation, understand basic operations on sets, and apply these concepts to solve problems. Let's get started. What is a set? A set is a well-defined collection of distinct objects considered as a single entity. So, for example, the set of natural numbers can be represented as 1, 2, 3, 4, dot, dot, dot. And another example is the set of vowels in the English alphabet, which can be represented as A, E, I, O, U. And sets are usually denoted by capital letters, such as capital A, capital B, capital C, while the elements of the set are denoted by lowercase letters, such as lowercase a, lowercase b, and lowercase c. Types of sets. So there are several types of sets. Finite Finite set is one that contains a limited number of elements. So for example, a set of 1, 2, 3 is a finite set because it has 3 elements. An infinite set contains an unlimited number of elements. So an example of this would be a set of natural numbers, 1, 2, 3, and so on. An empty set, or it's called null set, contains no elements and is represented as either an empty pair of curly braces or the symbol that signifies empty. A singleton set contains exactly one element, such as set of lowercase a. Finally, two sets are considered equal if they contain exactly the same elements. So for example, the sets of 1, 2, 3 and 3, 2, 1 are equal because they contain the same elements. So the order does not really matter. Set notation. There are ways to represent sets. The roster or tabular form lists all element of the set explicitly, and this is probably what you all are most familiar with. And there is a set builder form, which describes the properties that its members must satisfy. For example, a set A is x such that x is an even natural number. So this is how set builder form work. This means that set A contains all even natural numbers. And lastly, we have interval notation. And interval notation is used for sets of numbers within a certain range. So for example, this AB represent all numbers between A and B, excluding A and B themselves. Venn diagrams. Venn diagrams are a visual way to represent sets and their relationships. each set is represented by a circle, and the overlap between circles shows the intersection of sets. So, for example, if we have two sets A and B, the area where the two circles overlap represents the element that are in both set A and B. Basic set operations. So there are several fundamental operations that can be performed on sets. The union of sets A and B, denoted by A union B, includes all elements in either set A or set B or both. So for instance, 1, 2, 3 union 3, 4, 5 equals 1, 2, 3, 4, 5. The intersection of sets A and B, denoted as A intersection B, includes all elements that are in both set A and set B. So for example, 1, 2, 3 intersection 3 set of 3, 4, 5 equals 3. The difference of sets A and B, denoted as A difference B, includes elements that are in set A but not in set B. So if we have set 1, 2, 3 as A and set 3, 4, 5 as B, then A difference B is equal to 1, 2. Complement of set A includes all elements that are not in set A. So if U is a universal set, then A complement would equal universal set minus A. Properties of sets. Sets have several important properties. The commutative property states that the order of the union or intersection does not matter. So for example, A union B is equal to B union A, and A intersection B is the same as B intersection A. And we have the associative property, which states that the grouping of sets in a union or intersection does not matter. So for example, A union B union C is the same as A union grouping B union C, and similarly for intersection as well. And last property is the distributive property, which involves both union and intersection. So A union grouping of B intersection C is equal to A union B intersection of A union C, and it applies for intersection as well. Subsets and power sets. A subset is a set where all elements are also contained in another set. We say that set A is a subset of set B if every element of A is also an element of B. So for example, set of that contains 1 and 2 is a subset of set that contains 1, 2, and 3. And proper subset is a subset that is not equal to the original set. So set of 1, 2 is proper subset of set that contains 1, 2, and 3. And the power set of a set is the set of all possible subsets, uh, including the empty set and the set itself. So for example, if A is a set that contains 1 and 2, the power set of A, denoted as P of A, is a set that contains empty set, uh, set that contains 1, set that contains 2, and set that contains 1 and 2. Practical applications. So sets are not just theoretical constructs. They have many applications. So in computer science, sets are used in data structures, database theory, and algorithms. In logic, sets form the foundation of mathematical logic and proof techniques. In probability and statistics, sets are essential for understanding probability theory and conducting statistical analysis. Example problems. So here are some of the example problems for mathematical sets. Conclusion, to summarize, sets are fundamental mathematical objects that come in various types, including finite, infinite, empty, singleton, and equal sets. Basic operations on sets include union, intersection, difference, and complement. And these concepts have numerous practical applications in fields such as computer science, logic, and statistics. That's it for this lecture. Thank you everyone for listening.